running, and then multiple content. You need to have like multiple containers which are actually supposed to coordinate with each other. Like, so you need to create networks, and you need to make sure that the network is up and running. And also, if the container it gets killed by any chance, like so, you're supposed to maintain that particular container. So you're supposed.
ఇన్వర్టర్ మీద కాదనుకుంటాను ఇది అమ్మా ఈ లైట్లది ఇన్వర్టర్ మీద కాదు కదా
కరెంట్ పోయింది కదా. Okay, so this is what like we saw with Docker. So we spent like good amount of time in understanding what Docker is actually, and then how these containers are actually communicating with each other and all that stuff. Okay, so the volumes and all that information we saw. So now let's see like what this Kubernetes is actually, and how does this Kubernetes actually help us out. Okay. So basically like Kubernetes, so whenever like you see Kubernetes, like, so it is sometimes referred to as like KX. So it is nothing but like Kubernetes. So if you see like, so there are obviously like 8 items, I think 1, 2, 3, 4, 5, 6, 7, 8. So there are like 8 letters between K and ES. So that is why it is called as K8ES. Okay. So this is an interesting fact. Okay. So what is this actually Kubernetes? What is it actually used for? So this is actually used for container orchestration. So what is container orchestration? So whenever like when we are actually working with Docker, so some of the disadvantages which we saw with Docker is like basically like when a container is actually stopped, so maybe like there is a code issue or there is like some other issue, like so you're not able to communicate with, you're starting a MongoDB container and a Mongo Express container. So if the MongoDB container is started before this Mongo Express container, so obviously like it is working fine. But if the Mongo Express container is starting before the MongoDB container, so then there was an issue, right? So the MongoDB container, Mongo Express container, it used to fail. And when it used to fail, so we don't have an option to restart this container. So you need to manually check this particular thing, and then you need to make sure that like it is actually running. So there might be some code issue. So yeah, you actually have a .NET Core container, and you don't have like proper exception handling, and the container got killed. So obviously, like it is the responsibility of we guys to make sure that like the container is running all the time. So that is the difficulty with Docker. So it's like you have to take care of the entire life cycle of this container. So make sure that the containers are up and running and all that stuff. Okay. So this is where like the Kubernetes actually comes into rescue. Like, so with Kubernetes, so you'll be able to create uh, some specifications, and then once you create the specifications, so Kubernetes will always try to achieve that specification. So for example, like, so if you create a specification such that like, so you always wanted to have like 2 instances of Nginx, okay, in the specification file. So you have the specification, and then you gave the specification to Kubernetes. So now it's the responsibility of Kubernetes to always make sure that like, so there are 2 instances of this Nginx servers running. Okay. So if one is actually down because of some unhandled issues or any issues, like if one container is actually down, so Kubernetes will always make sure that like it is again like up and running. So another instance, like, so it is always making sure that like you have 2 instances of this Nginx running. Okay. So that is one of the example. Like, so also another thing is like, so it helps in network discovery. So network discovery in the sense like, so for example, like you might have multiple pods. So when you have like multiple pods, so you have multiple requirements. So such that like each of these containers, so they should communicate only internally, or you want these containers to communicate with external world or something like that. Okay. So in order to achieve this, like, so the same can be achieved even in Docker, but Kubernetes, it has like, it also does the same thing. Like, so it also provides this ability to, I mean, so identify it or communicate with a container. So using this container name, and also it also helps us in load balancing. Also, like you can create a load balancer, ingress, postgres. So these are all like different services that are actually offered by Kubernetes. Okay. So we'll see all these things like in depth, but I'm just giving a high level overview. So this is just like a theoretical one. From tomorrow, like we'll see the more practical one, just like Docker. Okay. So this is more about like service discovery and then load balancing. So if you have like 10 Nginx containers which are up and running, okay. So if you want to create a load balanced environment, like so you can just create like a load balance. So Kubernetes on the fly, like it has something called as load balancer as a service type and as a service. And then if you use that service, like you'll be able to load balance all these Nginx pods. Okay. And it has something called as external and then internal networking and all this stuff. Like external in the sense like you can expose this service to external world. Like internal in the sense like so if you wanted to expose only all these containers, like so for example like your database container, so you don't want to expose this to the external world, but this should be exposed to the API container. So in that case, like you'll be using like internal service. Okay. So that is one of the functionality that is offered by Kubernetes. Storage orchestration. So again, like storage orchestration. So you have this. So even this Docker Swarm. So Docker has a component called as Docker Swarm. Even it does the same thing like the container orchestration, but actually, so people prefer this Kubernetes. So because this was actually outsourced, this is an open source tool and this is widely adopted. Like so, all these cloud providers, so they widely adopt this Kubernetes. So you can create a cluster on any of these cloud providers like GCP or AWS or Azure, wherever. Like okay. So storage orchestration. So if you want to create, so basically with Kubernetes, like you can create like multiple storage types, like local storage, public cloud providers, and then you can also create like storage disks on Azure or GCP, and then attach it to these containers. Okay, so how easy it is like, so you can actually create this all this storage related orchestration in an AML file, and then you can just apply this particular. You can input this AML files to the Kubernetes. Like you can provide this AML file to the Kubernetes, and it will take care of creating the storage and all that stuff. Okay. So automated rollouts and rollbacks. So basically, like when we do deployment, so we have something called as like, so ideally, like what we do is like, so we down all our systems and then we deploy the latest code. And once the latest code is deployed, like we'll make sure that like our load balancer is pointing to this node new servers or something like that. Okay. So this is one way. So one of the drawbacks with this approach is like, so usually like you're actually deleting these old instances and or overwriting these old instances. And once these are overrated, so you're actually copying the new code or something like that. So one of the drawbacks with this approach is if something goes like, so after deploying, like you realize that like, so there is an issue in the code and your application is actually down. So now if you want to revert this back, so you have like a lot of challenges. Like, so you need to take the older version of code, and then you need to actually revert this new code that is actually deployed with the old code. Okay. So, so with Kubernetes, like you can also do that way. Like, so you can do deployments in that way, or like you can also do something like this. So for example, like I have like 10 instances of my ASP.NET code, which is actually running on 10 containers. Okay. So I have 10 containers of code which is running on ASP.NET containers. Okay. So now let's say like if I wanted to deploy something, if I wanted to make sure that like I wanted to deploy like 50% of these containers with the new code, and I also wanted to leave other 50% with the old code. Okay. So now in this case, like using Kubernetes, we can actually achieve this. So we can actually deploy like this 50%, the new code onto the 50% machines, and then another 50% onto, we'll leave the another 50% with the old code. So now Kubernetes has this ability where such that like, so you can also specify the traffic, like so how much traffic like you wanted to go to this new code and how much traffic like you wanted it to be executing on the old code. So that is one thing like which we can actually do, like, so that can be configured in Kubernetes. So that is one of the advantages. Okay. So self-healing. So self-healing in the sense, let's say like I have a .NET container and this .NET container. So we are not actually handling all these exceptions, and there is an unhandled exception uh, for example, like, so there is a divided by zero exception, or there is like a memory out of bound exception or something like that. Okay, because in our code. So once this container, so because of this, like the container is obviously killed, right? So once the container is killed in the Docker environment, like it is the responsibility of the developer to monitor this container and make sure that you restart this container, right? But with Kubernetes, so what I do is like, so I, in my initial deployment file, what I do is like, so I specify like I wanted to have like 10 instances of my code running on ASP.NET container. Okay. And when a request is hitting like container 5 or container 6, okay, so there is a memory out of bound exception on container 5. Okay. So, and that particular container, it got killed. So now we have only 9 containers left. So in ideal case, like with the Docker, like it is our responsibility to make sure that like we up this container such that like we always have 10 containers. Okay. But with Kubernetes, so it is the responsibility of Kubernetes to make sure that like it always maintains 10 containers. So when this sixth container, it is actually killed. So then Kubernetes makes sure that like we need to have like 10 containers. So it will create a new container with the specifications like which we provided initially. Okay, so that is all about self-healing. So secrets and configuration management. So Kubernetes also provides us like inbuilt capabilities where we can actually store these secrets, and then we can also use configuration management. Like you can actually, so you can actually store like in plain text, or you can also store the content in a base64 text or something like that. Okay. So it also provides you the ability to store secrets and the configuration related information. Okay. So let's see the Kubernetes architecture, like how Kubernetes actually. So basically with Docker, it's just like an image file like which we create, and then the Docker, whenever like you apply any Docker commands, like Docker run so and so image name, what it does is like, so it basically starts like the Docker engine will take care of starting this container, right? And once the container is actually finished executing its job, so if it doesn't have like any other job, like it gets killed. So if it is like a long running, like, so if we want to run this container forever, like, so you'll make sure that like, so you'll make sure that like it is running forever. Like, so in the Docker, like it is the responsibility of Docker engine to make sure to create all this container environment. Like, so whereas in Kubernetes, so it's apart from this Docker engine, like, so there is a lot which is available. Like, so for example, like this is the basic architecture of a Kubernetes cluster. Okay. So in Kubernetes cluster, we have two components, main components. One is like master node and the other one is like child nodes. So for example, like I have this master node and I also have like multiple child nodes. Nodes, okay. So usually the master node is actually responsible for creating all this. So in Kubernetes, like we don't regularly hear the term containers. So basically like with Docker, so container is the basic building block. So in Kubernetes, like behind the scenes, like, so we'll have this Docker and then the Kubernetes, but we don't actually hear this word like container more often. Okay. Containers are actually encapsulated by something called as pods. So this is like the master node and this is the child node. So when we see this master node, so again, we have something called as like API. So this is like Kubernetes API. And we have something called as etcd. This is like a key value store database. And we have something called as like schedulers. We also have something like control manager. So these are the different components in the master node. Okay. So basically, like what happens is, so the API, it is the first and the foremost important thing in the master node. I mean, almost everything is important, but first let's see like what an API is actually like. So an API is nothing but like, so anything like, so if you wanted to create like, as I mentioned, like, so I wanted to create like 10 instances of my ASP.NET Core container, right? So I need to inform this Kubernetes such that like, so Kubernetes, so take this image as an input and then I please create like 10 images, 10 containers for me. Okay. So I need to provide that information, right? So in order to interact with Kubernetes, so this is the thing like which we predominantly use. Like, so this is the one which we use. So any commands like which we issue to Kubernetes, so we issue them via these APIs. Okay. So Kubernetes APIs are the ones like which through which like we issue all these commands. So etcd, it is nothing but like, so etcd is a key value store database. So this like we have like multiple key value database stores, right? So the same way like etcd is again like a key value store database. So it's like the brain of Kubernetes. So this will etcd will actually contain this information. So for example, like I'm asking Kubernetes to create like 10 instances of my ASP.NET Core. So, and I also mentioned that like, so if there is an issue and one of these container is actually down, okay, so let's say like these are four instances of my nodes and these are hosting like four containers, okay. So if one of these containers is actually down, okay, so if this is actually down, okay. So what I said, like Kubernetes will actually create a new instance of this particular container again. So how does it actually how does it actually know? Like, so previously it is like four and now one is down and again, like I should create another container. So this information, we provide that information via the API and all this information, this is actually stored in the etcd. So this is the database which is used by the Kubernetes. So any information that is actually stored so by the Kubernetes, so it is actually stored in the etcd. Okay, schedulers are nothing but like, so these are actually used for creating these pods and then these containers, like starting these containers, all this stuff. Okay. So API, so Cube API server. So this is actually the control. So this is all called as like control plane. Okay. In the master node, so all these things are called as control plane. Okay, so they actually control these containers. Okay, so basically like creation of these containers and then making sure that like we have desired state of these containers and then managing the volumes, communications between these containers and all this stuff, okay, all these pods. So this is actually all these components are together called as control planes. Okay, so in the master node, like you can actually have a single instance of this master node, or you can have like multiple instances which are actually together like load balanced or something like that, and they can all be called as like a master node. So usually like in production environment, like we tend to have like more than one master node such that like, so if this is because like this is the master node is like the heart of this particular Kubernetes, right? So if this node is actually getting killed, like, so these are like EC2 instances or Azure instances. Okay. So on top of these instances, like we'll have all these softwares installed, like Kubernetes softwares installed. Okay. So if one master node is actually down, then the entire application is actually down. So that is the reason why like we always prefer to have like multiple replicas of these master nodes created in production environment. But in development environment, like on your local laptops, so you can have the master node as well as like this child node present on the same instance itself. Okay. So this is like API server. So in order to interact with the Kubernetes, so we interact via this API server. Okay. So etcd, as I mentioned, like, so this is a highly available key value store. So it's just like the database, like key value store database. Okay. Uh, so this is actually used for any backup plan. So for example, like if a container is actually down, like in order to achieve the desired state and all that information, so all the etcd is actually used. So scheduler, like the scheduler is actually responsible. So for example, like I have only one node. I have only one node. So node in the sense like you can actually consider this as like a virtual machine. So it can be like an EC2 instance or Azure instance or GCP instances or something like that. Okay. So this is a virtual machine. So on this, I have a single virtual machine, but I wanted to have like multiple instances of Nginx running, like Nginx running on this single instance. Okay. So what I do, so I'll provide an AML file to this API stating that like, so use this image like Nginx image and then create like two replicas of this Nginx image. Okay, so it is the responsibility of the scheduler to check like how many nodes are actually participating in this cluster. Like, okay, so in this case, like we have only one child node in the cluster. Okay, so now it sees like, okay, so this is a child node, and how many instances are how many containers we wanted to have. Like I wanted to have like two replicas of Nginx running. Okay, so then it tries to create like two Nginx instances in this particular child node. Also, like when we are actually creating these instances, so we can actually specify the RAM and all the stuff like hard disk and all these items. Okay. So let's say like my child node is actually 1 GB machine, like 1 GB virtual machine, and I created a deployment file such that like my instances, like I wanted to have like two instances of Nginx, two containers running Nginx, and each of these containers, so it should be occupying like 1 GB space, 1 GB RAM. Okay. So, but my child node, it has only 1 GB RAM. So obviously like with 1 GB RAM, like we cannot accommodate like two instances, right? So in that case, like it actually throws an exception or something like that. So it is actually taking the responsibility of scheduling these pods in different child nodes. Okay. So factors taken into account for scheduling decisions. So as I mentioned, like, so if there are like multiple, so if I have like multiple containers, multiple nodes, child nodes, I have like three child nodes. And if I'm actually specifying like I wanted to create like 5 instances of Nginx containers, okay. So we need to distribute, right? So three can actually go into three of these items, and then another two will be scheduled here. Like after a certain so let's say like we have two here, and then one. So after certain period of time, so I changed my mind and I decided to have like another container. Okay, so I wanted to have like six instances of these Nginx containers. Okay, so this is where like the scheduler actually comes into the picture, and it makes sure that like the load is actually distributed equally, and it tries to create, like I cannot actually guarantee that it will create this container in this particular node, but it tries to create, like it has its own algorithms and it has its own logic based on which like it decides like which onto which node a particular pod is supposed to be deployed. Okay. And some of the decisions, like some of the decision making things are like hardware and software constraints. Okay. Data locality. So for example, like if a container, it has like, so I have a MongoDB container or something like that. Okay. So, and I created like a local volume, something like that on this particular node. Okay. So there is no point in creating. So, and I wanted to create like two instances of this MongoDB container. So I have a local volume here. And I wanted to create like two instances of this particular MongoDB container. So do we have any point in creating like one instance over here, another instance over here? So we don't have any point, right? So because like if we create like here, so it needs to fetch this volume, like data from this particular local volume. So in that case, like it tries to create these two pods in this node itself, like, okay. So some of those decisions, so based on the hardware constraints and then software constraints and all these things, like it takes into consideration and then it tries to schedule these pods, create these pods. So this is more about so this control plane or the master node. Okay. So now let's see like what are all the components that are involved in this child nodes. So again, like just like master nodes, so child nodes, we can have like multiple nodes created which form a cluster. Okay, so if in this case, let's in this in example, like which you're seeing in the screen. So here, like I have three nodes which are actually participating. So these can be like three EC2 instances. So these are like three EC2 instances, like if we are talking about like AWS, okay, so three EC2 instances where I have where I can actually create these containers and pods. Okay. So basically, like if we take a particular node, so all the nodes that are actually participating in the Kubernetes cluster, so they have like some softwares, like, okay, so they have something called as like Cube. Um, So Cubelet, okay, I always get confused between Cubelet and kubectl. So this is Cubelet. Okay. So each of these nodes, so they have something called as kubelet. So the responsibility of this kubelet is something like this. So this is the one which actually makes sure that like the pod is running. Like so it actually so here like to the API, I'm just specifying like create like three instances of three containers, like three pods, three replicas of my Nginx server. Okay. So I'm just giving that information to my API, like Kubernetes API, and Kubernetes will actually store that information in etcd. So it stores this information stating that like, okay, so I need to always create three instances of this particular in the next container. Okay. So this master node, so it will actually communicate like the scheduler. It will actually check all this content, all these nodes, and then it tries to create like these pods on appropriate nodes, right? So once these nodes are actually created, so this is the kubectl, like the kubectl, which is actually creating these pods. Okay, so it takes these commands from this particular master nodes, and then the kubectl will execute like create these pods and all that stuff. Okay. So we'll have something called as kubectl. And another item which is actually which are present is like pods. So on single node, you can have like multiple pods. So these are like pods. So these are the pods. So kubelet is actually responsible. So it takes the pod specs, like pod spec in the sense, like so it takes this information which we provided to the API, and then it tries to create all these containers, so which are actually supposed to be running on this particular node. Okay. So another thing is like Kubelet doesn't actually manage containers which are not created by Kubernetes. So as I mentioned, like so this particular, this is a EC2 instance, right? So on this EC2 instance, like you can also have, like you can also manually log in into this EC2 instance, and then you can create your own containers. You can run a container, right? So, but Kubelet, it doesn't actually manage, like Kubernetes doesn't actually manage like any containers which were not created via this Kubernetes. Okay. So any containers which we create outside of this Kubernetes, so they are not actually managed by Kubernetes. So we have another component, like major component called as like Proxy. So Proxy is something.
No, small question.
Yeah.
So like, so if we create any container outside of this Kubernetes orchestration,
Okay.
so in order to access that, is there anything we can configure and we can access from the Kubernetes configuration?
No. So Kubernetes. So let's say your question is something like this. So I created a container which is actually outside of. I have like Docker
Outside
in
of,
there. Yeah.
right,
So
right.
without the Kubernetes, so we are actually creating this container, right? No. So there is no mechanism like so with which like we can actually tie these two things. Like okay.
Okay.
So we need to
Like
create this.
so I can, so in order to manage the thing, so the pod is down or pod is up, I don't know, right? If
Yeah.
the
Exactly.
container
So
is outside.
yeah, so if the container is started outside of this particular Kubernetes, so you'll not have any information present in this etcd and then the
Right.
schedulers and all this stuff, right? So
Hmm.
it's not actually possible to manage the containers that are created outside of this particular
Outside
Kubernetes.
of,
Okay.
oh,
Yeah. So Kubelet is actually responsible for taking these commands from this master node and then creating these pods, right? And we can have like multiple pods in a node. So ideally, like in the production environment, so they actually create like one specific pod for one node. Okay, so it's like a one-to-one relationship, but it all depends. Like so if we are okay to have like multiple pods running on the same instance, so we can also do that. But regular production uses, so it's just like a one-to-one suggested. Okay. So these are all pods. So these are pods, like, so in this case, like I have three different child nodes and each of these nodes have like three different pods. And these pods can be like multiple, I'll cover that, okay. So another item which we have is something called as Proxy, okay. So this is Proxy. And Proxy is actually responsible for the services, like so for the communication, network communication. Okay, so we, for example, like if this is, I just mentioned, like so I have three instances of my Nginx, and also let's take our regular example. Like so previously, like when we are actually working on Docker demo, so we saw like MongoDB and Mongo Express, right? So for example, like this one is like MongoDB container, and then this is like Mongo Express. So previously, like so we used to create all these networks and all this stuff in the Docker, right? So here, like we create like services. Okay, so this Mongo Express, so it cannot directly communicate with this Mongo. Like so, actually, like anything like any communication between multiple nodes, so you cannot actually do like direct communication. So it's the responsibility of Proxy. Like the request goes to Proxy, and then it is actually sent to the other node or some other container. Okay, so Proxy is actually responsible for the networking in Kubernetes. So even for the outbound, I just mentioned, right? So we can have like external load balanced environments, and we can have like external communication. So for example, like if I create like an external service, okay, so the MongoDB, it is exposed via this kube proxy to the external service. So same way, like if we have load balanced environment, like all these containers, like this is a MongoDB, this is a MongoDB, and this is a MongoDB. So they are all connected to this kube proxy to this external service, okay, load balanced service. So kube proxy is mainly responsible for networking. So now comes the important part. Like this is the main thing. Like so, without this container runtime, like Kubernetes, it's just like it's not actually useful, right? So basically, like when we are actually talking about Kubernetes and then Docker, so we interchangeably use these words for the container runtime. So whenever like we talk about container runtime, so we always assume that like Docker is the container runtime which is actually supported. Okay, so there are like other container runtimes which are also supported by Kubernetes, but Docker is one of the things like which is predominantly used. So we have something called as Rocket. So these are all so Rocket like, and this is Podman. So LXC. So these are all like different Docker alternatives. Okay, Container D is one of those container runtimes, but we predominantly use Docker in the Kubernetes. Like most of the people like, but there are other options. Okay. So never assume that like, so whenever like we are using Kubernetes, so it is always mandatory to use Docker. Okay, so it is not mandatory. And Kubernetes nowadays, like they're also trying to remove this dependency on the Docker also. Okay. So this is about the container runtime. So where does this container runtime? So the container runtime is actually present inside this node. Okay, something. So just like the Docker engine, we'll have this container runtime. This container runtime is actually responsible for creating of these containers. So now if we see in this entire architecture, we are not actually seeing real containers, like containers are nowhere mentioned here. Like so container runtime is actually a software which is actually used for maintenance of these containers. Like so starting these containers or killing these containers or the life cycle of this containers. Okay. But if we see like nowhere, like we are not actually seeing any of these containers. So basically a container is nothing but like, so you see pods, right? So container is a pod is just an encapsulation on top of a container. Okay. So it's just like an encapsulation. So usually like we can interchangeably use these words like pods and then containers can be interchangeably used. But in Kubernetes language, like whenever like we refer to a pod, like it has a container in it. Okay. Okay. So any questions till now? So on a high level, like this is the architecture of Kubernetes. So we have master nodes. So we can have like multiple master nodes. So this is again a clustered environment like master nodes. And in the same way, like we'll have child nodes, and these child nodes are again like we can have like multiple items. Like so, in this case, like I have three different child nodes. Okay, so in the master node, like we'll have API etcd, which is a key value database, and then key value store and the schedulers. Like schedulers are actually responsible for this. I mean, creating these pods like inside these containers, like which pod this particular container is supposed to be. I mean, which node this particular pod is supposed to be created. So all those decisions, so they are taken by these schedulers. Okay. So it is okay. So coming back to this child node, so you have something called as like Cubelet, so which is actually taking this specs. Okay, so it is taking this pod related specs, and it is the one like which is actually creating these pods. Okay, container runtime. So this is actually used to maintain these containers. So for example, like if we have Docker, so internally this container runtime, so this kubelet, it might actually issue these commands like docker start, docker run, all these commands to this kubelet will actually issue those commands to this container runtime. Okay. So, and we have something called as like Proxy, which is actually responsible for this networking. Okay. So this is the architecture of Kubernetes on a high level. Okay. Any questions? So does it look complicated when compared to Docker? So in Docker, it is pretty simple. Like, so we have very few commands. And with these few commands, like you're able to create containers and then you're able to run them. All right. But here, like we have master node, child nodes, and multiple components which are actually responsible for multiple things. So this looks complicated, right? But real time, like when we are actually deploying like large applications, so this actually comes into rescue like the Kubernetes. So you cannot actually monitor like thousands of containers, right? So you cannot monitor like thousands of containers and make sure that all these containers are always up and running, or if something is failing, like starting them and all this stuff like. So which is a difficult job. So which is actually handled by this Kubernetes very well. Okay. So
UA is available for this, right?
uh,
The
information.
configuration for the Kubernetes configuration part. So UA is available, so we need to do the
So there is
through
something called as a dashboard, like which is actually supported, but most of the times, like so we go with like AML files. Okay, so 90% of the time, like so we go with this AML files.
with the AML file.
Yeah. So because like if you see like these are all Linux environments, right? So these are all
Right.
predominantly used in the Linux world, and then they those people like so these Linux guys, so they're very much interested in issuing commands on the black one command prompt. So unlike the Windows guys, like who likes to click next, next, next.
Command line interface.
Yeah. So yeah, so we can actually interact with these APIs via. So these are like HTTP so APIs. Okay. So we can actually create these HTTP calls to interact with these APIs. But we use something called as like kubectl. Okay, so kubectl is the tool like which is actually used for interacting. So behind the scenes, like it actually makes calls to these APIs. Okay. So on your, I think like most of us are actually using Windows machines. So what you can actually do. So previously, like when we installed this Docker desktop, so by default, like Kubernetes, I don't think so. Like it is actually enabled. So there is an option called as like Kubernetes. So here, like you need to start this. So before actually doing that, so you need to go to settings. And once you go to settings, like you'll see something called as Kubernetes. Okay. So once you have this, go to this menu item. So you need to click on this enable Kubernetes. So once you enable this Kubernetes, so it actually restarts like so it and it will create like multiple containers for us like on behalf of us. Show it to you. Docker PS. So some of these items are like my Kubernetes also. So some of them are actually created via the Docker Compose and some with the Kubernetes. Okay. So this is how like you need to enable Kubernetes for local development on Windows machines. So you can go to this option like the Docker icon and then click on settings. Once you click on the settings, like you can go to Kubernetes and then click on check this box like enable Kubernetes. So by default, like Kubernetes is not enabled on Docker, so you need to enable it. So once this is actually done, So you'll see something called as like Kubernetes. So what is the context, like Docker context? Okay. So usually, like as I mentioned, like so basically like we provide like there are two things like so major items like which are actually present with Kubernetes object. So we mostly create these Kubernetes objects and then we issue them to this API, like we pass it to this master node via this API. Okay. So usually like all these Kubernetes objects, so they have like two important concepts. So like one is like the specs, and spec is the one like which is actually used to specify the desired state. Like, so for example, like in the spec, like I'll specify I want in the next containers running. How many containers I want? I want like 4 containers running. Okay. So that is the thing. Um, so we can actually use this command like kubectl command. Like so once you enable this particular Kubernetes, so then this kubectl command will be enabled for you. Like so if you don't enable this Kubernetes on this Docker container, so kubectl is not available. So apart from this kubectl, there is something called as like minikube, which I never used. So even it is actually used for issuing this, creating this Kubernetes environment in your local machines. Okay, so if you don't want to use this Docker desktop, so you can install something called as like minikube, and using that, like you can simulate this all these containers, master nodes, and then child nodes, all these things. So mostly like we in the Docker desktop environment, like so, or when we are actually having this Kubernetes clusters in a cloud environment, so we issue these objects like Kubernetes objects via this kubectl command. Okay, so this is also called as kubectl. So this API, we can also interact with this API via HTTP calls. But ideally, like what we prefer to do is like, so we create AML files and then we just apply these AML files to this Kubernetes engine. Okay. So I'll show you a sample AML file. Okay. So this is how like a sample AML file looks like. Okay. So as I mentioned, like, so we have something called as like a spec. So this is the spec part. So inside the spec part, like the selectors, like these selectors in the sense, like for example, like everything in Kubernetes is actually an AML file, like Kubernetes object. Okay. So for example, like if you want to create like a network, like if you wanted to create a network for communication between this Mongo and Mongo Express, so you need to create like a service. It can be like private service, node port service, or external service, or load balanced service. Okay. So you need to create a service, and the service can be created via an AML file. Okay. So if you want to create a pod, so you can actually create a pod via this AML file. Okay. So you have something called as deployments. So you have something called as replica sets. Okay. So deployment is nothing but like this is again a basic bare bone like deployments. We'll just see like so different kinds that are available. Okay. So services like even for volumes, like previously with volumes, like we used to issue these commands, right? So create volume, Docker create volume or something like that. So here, like we do that with volume files, okay? PV files, PVC files, and all this stuff. Like so, even they are AML files, okay? So for each and everything in Kubernetes, like we'll have one AML file defined, okay? So these are the basic things. Like so, this is how like an AML file looks like. So this is my deployment AML file. So the kind is deployment. So the same way, like you'll have like multiple kinds. So service is one kind, and then volumes is one kind. Okay, secrets, we talked about secrets, right, initially. So you can create a secrets. For secrets, you'll have like another AML file. Okay. So kind is actually very important. So kind actually defines like what type of Kubernetes object it is. Okay. So this is of type deployment. Okay. So API version. So which version of the APIs like Kubernetes APIs we are actually using. So this API version talks about the API version exposed used by Kubernetes. So this is just like metadata. Uh, what is this deployment file consists of? Like, so this is the metadata information spec. So as I mentioned, like the spec contains what is the desired state like we want. So in this spec, like what I'm mentioning is like, so I wanted to create like two replicas. So two replicas in the sense like I wanted to use this Nginx image, and this is the container spec. Okay, so I wanted to use this Nginx image and then create like two replicas of this particular Nginx image. Okay. And this is almost similar to the Docker compose file, which we saw in the past. Like, so you can specify ports, container port, like what is the port that is being exposed in the container, like 80. So if you have like any other um, environment variables, so you can just use them here. Okay. So this is just a deployment file. I'll also show you other files like which I use for my project. So you can actually see these are all different types. Like, okay, so here I'm creating a config map. Okay, so config map is nothing but like, so if you wanted to create like a configuration, like if you want to store any configuration. So in this case, like I just wanted to store this DB URL. Okay, so I can use this config map. So the kind is config map. So if I wanted to create a deployment, so this is the deployment. So deployment basically like the deployment actually takes care of creating these pods. Okay. And so yeah, so this is the deployment. So you can actually see these are the environment variables like which I'm actually using. So I can use like secrets. So this is my secret file, like of kind secret. Okay. So this is the service, like, so I wanted to expose this particular MongoDB, this particular identity management service to external world, right? So for that, like what I'm actually doing, so I'm doing like a node port. So node port is nothing but like it is one type of service. Like, so previously, like in Docker, we saw multiple types like bridge network and all those network types, right? So the same way, like here, like we have something called as node port, load balancer, ingress, all these things. Okay. So node port is nothing but like, so if you wanted to expose your container just to the host machine, okay. So for example, so this is my MongoDB container and this is my MongoDB Express container. Okay. So I want to establish connectivity between these two, Mongo and then Mongo Express. Okay. So in that case, like I can actually create like a node port or internal service. Okay. So protocol, which protocol, what's the port, like target port, and then so node port, it has like specific port range. So you can only use like ports starting from 31000 to something else. Like I don't exactly remember right now, but we'll see, we'll cover all of this. Okay. But you can actually see like we have different types of AML files created for each of these things. Okay. And if you want to apply a specific YAML file, so what you need to do is like, so you can simply go and execute this command something. So let's say like I wanted to apply this command, like, okay. So I wanted to apply this deployment. I wanted to create like two instances of this particular Nginx container, right? So let me go to PowerShell. So let's check like Docker PS. So you can actually see I don't have this Nginx servers, like 3 instances of Nginx. So these are like different images, right? You can actually see. So I don't have Nginx. So what I can actually do is, so this is my deployment file. So here I'm just specifying I wanted to create like 2 instances of this particular Nginx. Okay. So I can simply do kubectl apply -f and my deployment file name. So here it is like deployment.aml. So the response is something like this: deployment created. Now, if I see Docker kubectl type, kubectl describe deployments. Kubectl describe deployment.
kubectl get deployment. Get deployments. Kubectl get pods.
So I wanted to describe this kubectl get pods. So you can actually see like get pods. So it is actually running like two different pods. Like okay. So let's say like this is my pod, right? Kubectl delete delete pod. So I'm just deleting this GS946. And if we see get pods again, so another pod it got created like so this was created 2 minutes back and this is actually created like 9 seconds back. Okay. So Kubernetes is actually responsible for maintaining the state. So because like I mentioned, two different replicas to be created, so it is actually creating. It is always trying to maintain the state. Okay. So deployment. So kubectl get deployment, and then we can use kubectl describe. So this is the deployment like which we created, like kubectl describe deployment. So it gives some metadata like, okay. So you can see rolling update strategy, 25% max unavailable max search. So rolling updates in the sense like as we mentioned in the past, like as we discussed, like so when we wanted to create like 25% of my nodes with like new code. So that is where like these are all this comes into picture. Like we'll see all those things in detail. Okay, so the pod template, if you see the pod template, like what is the label? So it is actually using like the app label is Nginx. So this is the label Nginx. So it is actually using this image like Nginx as okay. So this is the deployment, and then these are the pods like kubectl get pods. So if you want to see a specific pod details. Okay, so this is the pod related information, all the network related information, and all these things like. So you can actually see Istio and all this stuff. So this is actually related to a concept called a service mesh. Okay. So usually sidecar pattern, and we'll see all those things. So you can also see the events like the scheduler successfully assigned this deployment to Docker desktop. Okay. So after that, like container image. So I already have this proxy image, like, and then it started creating the container. Like then it started pulling this particular image, and then once the image is pulled, it started creating the container. So if there is an issue at any point, like we can actually use this information to see like where exactly it failed or something like that. Okay. So this is the basic things like so the Kubernetes. So going forward, like we'll see more in depth. Okay. So any questions for today? And if we want to delete like a deployment, kubectl delete deployment. So I can use this deployment file. You should actually, so I should actually get my cheat sheet. So kubectl get
kubectl delete deployment -f. We have to give
hyphen minus f, right? Yeah, we need to specify the file deployment minus f. Yeah. File, like we can also delete this file. CTL deployments. So this is my deployment, right? So if I wanted to delete this deployment, kubectl deployment, so it got deleted. Like, but we can also delete this file.
kubectl delete -f. You have to remove deployment.
Okay, okay. Deployment is not actually required. Okay. Yeah, this one is not actually required.
Yes.
So this should ideally work. Okay.
Yeah.
Yeah, so this is more about like Kubernetes, like the basic intro of Kubernetes. We'll see all those things like in detail from tomorrow. Okay. Okay, guys. So if no questions, so we can actually drop.
Thank you, Pavan.
Yeah, thank you, guys.
Okay,
Bye.
yeah, thanks.
Thank you. Yeah.
Bye.
Thank you.